Good afternoon, everyone. Welcome to Gate Wala. How is everyone doing? How is your preparation going on? Good afternoon. We are in the last month of Gate preparation, right? Because next month you will write your Gate 2025, and I hope all of you are ready. Now, this is the last leg of your preparation where we are conducting various sessions for you. We have Maha revision classes in order to revise the entire theory and concepts. Yesterday there was a Maha revision of basic thermodynamics. Tomorrow there will be Maha revision of strength of material. Okay, so you must attend all these Maha revision classes. Tomorrow we will have strength of materials Maha revision at 4 p.m. in our Gate Wala MEPIXC channel. Okay, so all of you are invited. Okay, that will be for your theory and concepts, and for your practice we have two sessions. We have Maha Abhyas as well as revision through PYQs. So in revision through PYQs we will be solving all the important previous year questions, and in Maha Abhyas we will be solving all the new questions. So every other day at 2 p.m. you will have your revision through PYQs, and at 7 p.m. will have your Maha Abhyas. Okay, so revision through PYQs will be on Gate Wala English channel, and your Maha Abhyas will be in Gate Wala MEPIXC channel. Okay, so today at 7 p.m. you will have your Maha Abhyas of thermodynamics. Okay, so don't forget to attend that. Okay, so all of you, if you are not in this group, which is our Telegram group for all your doubts, your queries, join this, scan the QR code, or just search for this name and follow this Telegram group. Okay, whatever doubts you have, whatever queries you have, we will be answering those queries and doubts 24/7 in this Telegram. Without any further delay, let's start with our revision through PYQs. So we'll be solving all the important PYQs, okay, which are probably gonna be there in Gate 2025. I hope all of you are ready. Everyone is ready? Shall we start? Class duration, it will be around 3 hours. Okay, minimum 3 hours. Chalo. So let's begin with our first question, and this is one of the very important questions. You have a stress strain graph, and from this graph they will be asking you to calculate the modulus of resilience or modulus of toughness. Okay, so what is the question? A hypothetical engineering stress strain curve shown in figure has three straight lines PQ, QR and RS with coordinates 0, 0, 0.200, 0.6140 and 0.8130. Q is the yield point, R is the ultimate strength point, and S is the fracture point. Toughness of the material in megajoule per meter cube is. Now this is very important. They are asking you modulus of toughness, right? Modulus of toughness means toughness per unit volume. So it will be equal to the area of the stress strain curve. Yes, this was in Gate 2016, and probably there might be a question from stress strain curve this year also. So this is very important. Now in this particular question, a lot of students make this mistake. So keep this in mind. Here the stress is given in megapascal, means Newton per mm square. Okay, and the strain is given in percent. Now what do we mean by percent strain? What do we mean by percent strain, beta? Percent strain, 100 times of strain, right? It is 100 into epsilon. So epsilon will be percent divided by 100. This is very important to keep in mind. Lot of students make mistake. In fact, I remember in Gate 2016, a lot of my students made this mistake. They forgot to divide this percent strain by 100. They got the wrong answer. This was a very simple question, but still a lot of students made mistakes in solving this question. Okay, so whenever you have a graph, keep in mind to note the units of x and y axis. Okay, chalo. Now how do we calculate the Modulus of toughness by calculating the area. So here we can divide this area into three parts. One triangle and two trapezoid. Area of triangle is half into base into height, and area of trapezoid is half into base into sum of parallel sides. Okay. So modulus of toughness, let me denote it by UT. It will be equal to half into base. This base is 0.2, but it is 0.2%. So I have to divide it by 100. 0.2 by 100 into height. What is this height? 100. Plus area of trapezoid, half into base into sum of parallel sides. What is this base? This base is 0.4, right? This base is 0.4. 0.4 by 100 multiplied by sum of parallel sides. So this is 100 and this is 140. 100 plus 140 plus half into, what is this base? 0.2 and sum of parallel sides 140 and 130. So from here you will get modulus of toughness. Okay, how much is it? How much is it? I am getting 0.85, right? But what is the unit? Now this is very important, especially when there is a NAT question. Okay, you have to put the answer in the unit that is mentioned. So here the unit mentioned is megajoule per meter cube. Now what is R unit? What is R unit, beta? R unit is Newton per mm square, because strain has no unit and stress megapascal means Newton per mm square, right? Now understand again, megajoule per meter cube means what? Megajoule per meter cube means what? Joule means Newton meter, right? So it is mega Newton per meter square, na? It is mega Newton per meter square, right? Now if I convert mm into meter into mm, what you are going to get, beta? What you are going to get? Mm into 10 to the power 6. So this mega and this 10 to the power 6 will be cancelled, na? Because mega is also 10 to the power 6. So this is equal to nothing but Newton per mm square only. Yes. So megajoule per meter cube is actually equal to Newton per mm square. Okay, do you understand? Mega means 10 to the power 6. Joule is Newton meter. So this is mega Newton per meter square. So if I convert meter into mm, you will get 10 to the power 6. 10 to the power 6, 10 to the power 6 cancelled. So Newton per mm square. Megajoule per meter cube, Newton per mm square. So this is the answer. Okay, everyone is clear? Chalo. So this is one of the very important question based on stress strain curve. I am hoping that one question will be there this year from stress strain curve. Okay, let's move on to the next question. Now this is another question, very interesting one from GATE 2016 only. A square plate of dimension L by L is subjected to uniform pressure. Okay, you can see that the pressure is applied in X as well as in Y directions. P is 250 megapascal and this will be equal to the stress. So you can say that the stress in X and Y direction is 250 megapascal. Assume plane stress condition, Young's modulus is 200 gigapascal. Deformed shape is a square of L minus 2 delta. So you can see that initially the dimension was L by L. Then there was a deformation of 2 delta in X direction as well as in Y direction. Delta here delta here. So what is the total deformation, beta? Total deformation is 2 delta. Okay. So L is equal to 2 meter, delta is equal to 0.001 meter. Poisson's ratio they are asking. Now here we have sigma x as well as sigma y. So in any direction, if you calculate the strain, what formula you are going to use, beta? Are you going to use this formula? Sigma epsilon x is equal to sigma x by E minus mu sigma y by E. Yes, we are going to use this formula. So using this formula, we will be solving this problem because we have epsilon x, sigma x and sigma y E. We need the value of nu. Okay. Now epsilon x will be equal to how much? Epsilon x will be equal to deformation in x divided by original length in x. What is the deformation in x? Minus 2 delta. Delta here, delta here. Total deformation in x is minus 2 delta divided by L equal to sigma x by E minus nu sigma y by E. Now put all the values in this equation. So beta, what is delta? Delta is 0.001 meter. So I will put it in meter and length also in meter. See that meter units are cancelled. Is this point clear? Don't worry that I am putting the values in meter because meter above, meter below both will be cancelled. So no issue. Now sigma x is 250 megapascal, but it is compressive. So this will be minus 250. Young's modulus is 200 gigapascal, so I will convert it in megapascal. Again here sigma y is also minus 250. So in this equation there is only one unknown nu. What is the value of nu? What is the value of nu? Point 2 everyone is getting? Everyone is getting point 2. Yes. Chalo. This is clear to everyone. This was in GATE 2016. Okay. Let's move on to the next question. Now this is from GATE 2017. Okay. A rod of length 20 mm is stretched to make a rod of length 40 mm. Subsequently, it is compressed to make a rod of final length 10 mm. Now this is based on the concept of true stress strain. Remember, in calculating true strain, we only consider the initial and the final length. In between what is happening, it doesn't matter. So initially it was 20 mm, then it was compressed to expanded to 40, then it was compressed to 10. But you don't need to consider this. Only consider the initial and the final. Consider longitudinal strain positive and tensile strain as positive and compressive strain as negative. Total true longitudinal strain is, what is the formula of longitudinal strain, true strain? Natural log of final length by original length, right? Now what is the final length? Final length is 10 mm and original length is 20 mm. What is happening in between? It doesn't matter. So natural log of 0.5 is minus. Now let me tell you the very important PYQs because it has been repeated twice. Okay, this same question came twice in GATE. So this is very important. Okay, you might get a similar question like this. Okay, so one of very important PYQs, because this was repeated in GATE. Okay, it's a very rare condition, it's a very rare situation that you get repeated PYQs. You might get PYQs based on the same concept, but getting the same PYQ, same data, same answer, that is a very rare situation. Okay, chalo, let's move on. Now this is from GATE 2018. Again, a question based on stress strain curve. Okay, very important one. The true stress, true strain diagram of strain hardening material is shown in figure. First, there is a loading up to point A, that is up to a stress of 500 megapascal and a strain of 0.5. Then from that point A, there is unloading up to point B. Given that Young's modulus is 200 gigapascal, natural strain at point B is, understand beta, this is very important because a lot of people don't look at this point. Okay, they are asking you to calculate natural strain. Beta, what is natural strain? Can anyone tell me what is natural strain? Natural strain is actually true strain. This is the actual strain. Okay, natural strain means true strain. This is very important because if they are asking you to calculate the engineering strain, the answer will be different. In this graph, whatever strain they have given you, it is true strain. So if they are asking you to calculate engineering strain, it means whatever answer you will get from the graph, you will have to then convert it into engineering strain. But here they are asking you to calculate natural strain only. It means you don't have to convert anything. Just solve this diagram, get the answer. This is very important point, okay? Because if they give you this engineering strain, the answer will be completely different. Chalo. So now in this question, they are asking you to find this epsilon B. They are asking you to find the strain at this point. So how do we calculate the strain at this point? Look at this triangle. Look at this triangle. In this triangle, you know the slope of this straight line. Slope of the unloading curve is equal to Young's modulus, right? So this slope E will be equal to, what is this? dy. What is this dy? 500 minus 100, na? 400. I will write it like this: E sigma by d epsilon. So slope is equal to how much? Young's modulus is equal to how much? 200 gigapascal. 200 into 10 to the power 3 is equal to 500 minus 100. This dy is 400. Dx will be 0.5. This is 0.5. This is epsilon b. So 0.5 minus epsilon b. So from here you will get the value of dy by dx. This is dx. What will be dx? 0.5 minus epsilon b. This will be equal to this. Okay. So from here, what is the value of epsilon b? Everyone is getting 0.498. Everyone is getting 0.498. But if they ask you to calculate engineering strain, what will be your answer? Tell me. If they ask you to calculate engineering strain instead of natural strain, if I ask you to calculate engineering strain, what will be your answer? What is the relation between engineering strain and true strain? True strain is natural log of 1 plus engineering strain. Engineering strain will be equal to e to the power true strain minus 1. So e to the power 0.498 minus 1, which will be 0.645. Okay, 0.645. Lot of people have interchanged these values. They have put epsilon t here and epsilon e here. So this is what? This is lack of revision. Okay, this is lack of revision plus overconfidence. Lot of people know the formula, but they just become overconfident. They just become very excited. Oh, this is very easy. I know this. And then they make this mistake. Okay, just like our 𝐂𝐬𝐬𝐬 here. Natural log of 1 plus epsilon e is equal to epsilon t. What you got here is epsilon t, not epsilon e. You are not converting engineering strain to true strain. You are converting true strain to engineering strain. Remember this. Such a silly mistake. Chalo. A steel cubic block of side 200 mm is subjected to hydrostatic pressure of 250 megapascal. Okay. Elastic modulus is 2 into 10 to the power 5 and Poisson's ratio is 0.3. Side of the block is reduced by. This was in GATE 2021, only 1 mark question, but this is again important. Similar question was there in I think 2023 or 2024, right? Similar question. A steel cubic block of side 200 mm. So each side is of 200 mm. It is subjected to hydrostatic pressure, means sigma x, sigma y, sigma z. All are 250 megapascal. Young's modulus and Poisson's ratio are given. The side is reduced by. So let's say epsilon x will be equal to sigma x by e minus nu sigma y by e minus nu sigma z by e. Now epsilon x will be delta x by x. Sigma x, sigma y, sigma z all are same. So I can write it like this, or I can write it like this. Now put the values here. So you need delta x. What is the original x? 200. Sigma is equal to 250 megapascal. Poisson's ratio is 0.3 and Young's modulus is 2 into 10 to the power 5. We have put all the values here. What will be the value of delta x? What will be the value of delta x? 250 into 200, 1 minus 2 into 0.3 divided by 2 into 10 to the power 5. 0.1, everyone is getting 0.1. 0.1 mm. Yes? Very good. Excellent. All these questions are from material properties. So we are moving chapter by chapter. Okay, we are solving the PYQs chapter by chapter. Okay, again a question of true stress strain. This is power law. This is the question based on power law. Okay, the true stress versus true strain relation of a material is given by sigma equal to 1020 epsilon to the power 0.4. Cross sectional area at the start of test is 100 mm square. Let me remind you, last year also there was a question based on true stress strain relation. So these type of questions are repeatedly asked. In the last 5-6 years, I have seen 3 questions based on power law. Last 5-6 years, okay, 3 questions based on power law. Very important PYQ. Okay, cross sectional area at the start of test is 100 mm square. Cross sectional area at the time of necking is. How do we calculate it? First of all, you must remember power law. Power law is a relation between true stress and true strain during plastic deformation. Yes, and we know at the time of necking, when the necking starts, when necking starts at ultimate point, at the time of necking, epsilon t and n both are equal. Yes, what is the value of n? Here the value of n is 0.4, so your epsilon t will be equal to 0.4. Now, epsilon t is natural log of L final by L original. Yes, this is clear to everyone. But here they are asking you to find the area, the length. So how do we solve this? Remember, when we were deriving the relation between true stress strain and engineering stress, we assumed that volume remains constant. I hope you guys remember this. We assumed. This is not actually true. The volume changes a little bit during the elastic deformation, but we assume that the volume remains constant. So from here, L final by L original is equal to A original by A final. L final by L original is equal to A original by A final. We use this relation when we derive relation between engineering stress strain and true stress. So this will become A original by A. So 0.4 is equal to natural log of original area is how much? 100 mm square. From here you can write 100 upon A final is equal to anti-log of 0.4, e to the power 0.4. A final is equal to how much? 100 divided by e to the power 0.4, 67.03. Very good. Very good, everyone. So here you need to remember this power law, and also you need to remember this relation. We assume that volume remains constant. So from here we get L final by L original is equal to A original by A final. So replace L final by L original with A original by A final, you get this, and from here you get area. Okay, very important question. Chalo, let's move on to the next chapter, axially loaded members. And I told you that almost every other year you get a question from axially loaded member. This is one of the most important chapters in strength of material. In fact, last year also in 2024 there was a question from axially loaded member, strain energy calculation, right? Bar subjected to self weight. A horizontal bar with constant cross section is subjected to loading as shown. Young's modulus for AB is 3E and for BC it is E. For the deflection at C to be 0, ratio P by F is. What is the deflection at C? What do we mean by deflection at C? They are asking you to put deflection at C equal to 0. What is deflection at C? Deflection at C means change in length from A to C, right? Means change in length of AB plus change in length of BC equal to 0. Now just put the values here. Delta L is equal to PL by AE. What is the internal force in AB? internal force in AB will be equal to the total force on the right side of this section, which is equal to F minus P, right? F minus P. What is the length of AB? L. Then area and Young's modulus is 3E. Then change in length of BC. If I take a section in BC, on the right side force only F. Length is L, area is A, Young's modulus is E. So this, if I multiply this equation with 3, this will become F minus plus 3F equal to 0, means 4S minus P equal to 0, 4F is equal to P. Now they are asking you to calculate P by F. So P by F will be equal to 4. Some of the students have calculated F by P. See, these are minute mistakes, minor mistakes. Let me tell you, right now these are minor mistakes, but in the exam it is going to cost you a lot of marks. This is going to be a very big mistake in exam. Try to avoid such kind of mistakes. If they are asking you to calculate the ratio of two variables, need to see which one is in numerator, which one is in denominator. Okay, so they are asking you P by F, not F by P. Okay, so P by F is equal to 4. Okay, chalo. Let's move on to the next question. Now this is from GATE 2021. Very interesting question of body subjected to self weight. Write solid circular cone. Okay. Write solid circular cone standing on its base on a horizontal surface is of height h and base radius r. The cone is made of material with specific weight W and elastic modulus E. Vertical deflection at the mid height of the cone due to self weight is given by. See, we have a cone like this, resting on a horizontal surface. Height of the cone is h and base radius is r. Okay. Now they are asking you to calculate vertical deflection at the mid height. Let's say this is point A, this is point B, this is point C. They are asking you to calculate vertical deflection of B. So how do you calculate the vertical deflection of B? First of all, you need to remember this. Even if the problem is like this or like this, you can use the same concept, you can use the same formula. We derived the formula of this case, right? But in this case also the formula will remain same. What was the formula? Gamma L square by 6E. But that is the vertical deflection of this point. If I calculate the vertical deflection of A, will be gamma L square by 6, or in this case WH square by 6. But they are asking to find vertical deflection of B. Now we have covered this concept. In class. If I want to calculate vertical deflection of B, I cannot just put h by 2 here. Why we can't put h by 2 here? Because beta, when we calculate the vertical deflection of B, see, you cannot ignore this when you are calculating the change in length of AB, right? When you are calculating the change in length of AB, you cannot ignore BC. BC is also pulling AB, na? BC is also pulling AB, right? So how do you calculate the vertical deflection of B? Calculate vertical deflection of B like this. Vertical deflection of A, or you can see this. Change in length of AC. Oh, so sorry. So sorry. I made a mistake here. I made a mistake here. We can do this. We can do this. See. It is like this. A, B, C. Okay. So you can consider AB separately. You cannot consider BC separately. So sorry, I made mistake here. You can consider AB separately. Okay. You cannot consider BC separately, because if you consider BC, then AB will also be responsible for the deformation of BC, right? So understand this. What will be delta B, beta? Delta B will be equal to change in length of BC, right? Delta B will be equal to change in length of BC. But can you calculate the change in length of BC? No, you don't know the formula of this body, na? You know the formula of this. You also know the formula of this. This is also a cone. This is also a cone. But this is not a cone. So how do you calculate the change in length of BC? Calculate change in length of BC by doing this. Change in length of AC minus change in length of AB. Yes or no? Yes or no? If you want to calculate vertical deflection of B, you need delta L BC. But you don't know the formula for BC. You know the formula for AC. You know the formula for AB. So now what you need to do is delta B will be equal to WH square by 60 minus WH by 2 square by 60. That's it. In case of AC, L will be equal to H, and in case of AB, L will be equal to H by 2. So from here, delta B will be equal to how much, beta? 1 minus 1 by 4, 3 by 4, na? So this will become WH square by 8E. Right? The answer will be this. A. Is this point clear? Vertical deflection of B will be equal to change in length from B to C, because C is the fixed point. So you need delta L BC, but you don't know the formula for delta L BC. You know the formula for delta L AC. You also know the formula for delta L AB. So we used this to calculate change in length of BC. Okay. Chalo, moving on to next question. Now this is another important question. Okay. A horizontal bar fixed at one end has a length of 1 meter and cross sectional area 100 mm. Let's say this is the horizontal bar. Okay. Young's modulus varies with length. Using this equation. This is the equation of Young's modulus, which is varying with x. X is the length coordinate along the axis of the bar. Axial load of 10 kilonewton is applied at x equal to 1 meter. Like this. Now they are asking you what will be the axial displacement of the free end. How do you solve this question? In this question, Young's modulus is not constant, and I told you whenever any quantity is not constant, you need to use the integration formula. What is the integration formula beta for delta L? This is the formula which we use when any quantity is not constant with respect to along the length. So here Young's modulus is not constant along the length. Yes. So you just need to put the equation of Young's modulus in this formula. Other values are constant. P is constant, A is constant. Just put the formula. But understand this, very important. In this formula, what is the unit of X? X is in meter. So if you are using this formula, you have to convert everything in meter. Clear? Everyone clear? This is a very important point. Otherwise you will get wrong answer. If you are using this formula, see, we got one wrong answer already. This is due to wrong units. If you are using this formula, then here X is in meter. So put everything in meter. So let me convert all the values in SI unit. Okay. So what will be the limit of length 0 to L? And what is the value of L? L is 1 meter. So here I will put L in 1 meter. Then force is in kilonewton. We will convert it in Newton. So 10 into 10 to the power 3. Area is how much? Area is 100 mm square. Convert it in meter square. So 100 into 10 to the power minus 6. 1 mm is 10 to the power minus 3. Mm square means 10 to the power minus 6. Okay. Young's modulus is given in gigapascal. Gigapascal means 10 to the power 9 Pascal. So this will become 100 e to the power minus x into 10 to the power 9. If you solve this, you will get the value of delta L. Do you guys understand what I have done? I have put x in meter. So I have put everything in meter. Then this is 100 e to the power minus x gigapascal. Convert it in Pascal. We are putting everything in SI unit. Don't convert it in megapascal. Convert it in Pascal. We are putting everything in SI unit. Okay. So if you integrate this 0 to 1, 10 into 10 to the power 3 divided by 100 into 10 to the power minus 6 plus 100 into 10 to the into 100 into 10 to the power 9 into e to the power minus x. What is the answer? 1.178. 1.718 into 10 to the power minus 3 meter. But they are asking you to calculate it in mm. So it will be 1.718. Got the right answer, everyone? Okay, very good, excellent. Avoid such mistakes. Is everyone clear? Avoid such mistakes. Whenever some equation is given, it is very important to see what is the unit of these variables. The unit of these. Okay. Whether this x is in meter or mm. If they give you x in mm, then put everything in mm. If they give you x in centimeter, then put everything in centimeter. Okay. Hello. A solid cube of side 1 meter is kept at room temperature of 32 degrees centigrade. Coefficient of linear thermal expansion is 1 into 10 to the power minus 5 per degree centigrade. And bulk modulus is 200 gigapascal. If the cube is constrained all around and heated uniformly to 42, then the magnitude of volumetric stress is. If you have a cube which is constrained in all directions, and if you heat it, you will get thermal stress in all 3 directions. Yes or no? You will get thermal stress in all three directions, and in all three directions the thermal stress will be equal. Yes or no? In all directions the thermal stress will be equal. This will be sigma, this will be sigma, this will be. And what will be the value of this sigma? This sigma will be equal to E alpha delta T 1 minus 2 nu. Remember, we derived this formula in the class. If the body is constrained in only one direction, the formula is E alpha delta T. If it is constrained in two directions, the formula is E alpha delta T upon 1 minus nu. And if it is constrained in all three directions, the formula is E alpha delta T upon 1 minus. See, we will revise all these formulas and concepts tomorrow. Tomorrow there will be Maha revision of strength of material. In which channel? Gate wala MEC XCH channel. Gate wala mechanical channel, we have a separate channel for that. So in that channel, tomorrow at 4 PM, we are going to revise all the concepts of strength of material. Okay. Now here beta, they have not given you Young's modulus and Poisson's ratio. They have given you bulk modulus. What is the relation Young's modulus and bulk modulus? E is equal to K1 minus. So from here, K will be equal to, from here, upon 1 minus will be equal to K. Yes. So sigma will be 3K alpha delta T. Na? This formula will become this formula. Yes. Now another very important point. Again, some people can make mistake here. K is 200 gigapascal, 200 into 10 to the power 3. Alpha is how much? 1 into 10 to the power minus 5. Now what is delta T? So what a lot of people make mistake here is they put delta T equal to 42. It is heated to 42 degrees centigrade, not by 42 degrees centigrade. Heated by 42 means delta T is 42. Heated to 42 degrees centigrade means this is the final temperature. So initial temperature is 32, final temperature is 42. What is the change in temperature? Change in temperature is only 10. So this will be your sigma, which is also known as volumetric stress. Mean stress, volumetric stress, hydrostatic stress, you can call it anything. Okay, they are asking you to calculate volumetric or mean stress. Na? So this same sigma can be called mean stress, volumetric stress, average stress, thermal stress, or hydrostatic stress. Okay. Chalo. Everyone is clear? Let's move on to next question. Now this is an interesting question from GATE 2018. A bimetallic cylindrical bar. Bimetallic means it is made of two different materials. Okay. Cross sectional area 1 meter square is made by bonding steel and aluminum. Young's modulus of steel is 210 gigapascal. Young's modulus of aluminum 3 gigapascal. To maintain tensile axial strain of magnitude 10 to the power minus steel bar and compressive axial strain of 10 to the power minus 6 in aluminum bar, magnitude of required force P along the indicated direction. What they are asking is, if you apply a force here, you get a tensile strain in steel and a compressive strain in aluminum equal and opposite. How much? 10 to the power minus 6. What should be the value of this P? Now in order to calculate this P, what we are going to do, here we are applying a force P. Let's say the reactions developed here is R, here is also, sorry, let's say this is R1, this is R2. Okay, if you know R1 and R2, you can calculate P. Yes or no? What will be, this is steel, this is aluminum, huh? Steel, this is aluminum. What will be the internal force in steel? What will be the internal force in steel? Can I say internal force in steel will be R1? And what will be internal force in aluminum? What will be the internal force in aluminum? Can I say internal force in aluminum will be R1 minus? Yes? Very good. Now understand. Epsilon steel is equal to 10 to the power minus, right? Strain in steel is tensile, it is 10 to the power minus, okay, and epsilon steel will be change in length of steel divided by original length of steel. So change in length of steel is equal to how much? This much. Yes? The value of is value of L given? Hello. Now change in length of steel will be P of steel into length of steel, area of steel into Young's modulus of steel. This LS will be cancelled. This is P of steel, R1. R1 divided by area is how much? 1 meter square, Young's modulus is 210 gigapascal, right? Can I write it like this? R1 will be equal to how much? 210 into 10 to the power 3 Newton, or R1 will be 210 kilonewton. You are getting this? Yes? R1 will be 210. We have got the value of R1 from epsilon of steel. Now epsilon of aluminum, it is minus 10 to the power minus, because epsilon of aluminum is compressive, negative, minus 10 to the power minus 6. Okay, so this will be change in length of aluminum by original length of aluminum. This will be P of aluminum, L of aluminum, A of aluminum, E of aluminum equal to this. Again, these two will be cancelled. Now, what is the internal force in aluminum? So, internal force in aluminum you can put from right side also, or you can put from left side also. Okay, some people are saying why you are not putting from right side. Let's put it from right side. Now, let's put minus R2. Doesn't matter. Okay, so here it will become how much? minus R2 divided by, what is the area of aluminum? Same, 1 meter square. Young's modulus will be 70 gigapascal. Minus minus will be cancelled. R2 will be 70 into power 3 Newton or 70 kilonewton. Okay, that's it. So we have got the value of R1 and R2. Now beta, in this diagram, if you put summation of fx equals to 0, what you will get? Let me copy this diagram. From here, summation of fx equals to 0, you will get P equal to R1 plus R2. So R1 is 210, R2 is 70. We will get 280 kilonewton. Yes. R1 plus R2 na. P equal to R1 plus R2. It will depend upon the direction you have assumed. I have assumed R1 and R2 like this. If you assume R2 like this, then here your R2 will be negative. You will still get the same answer. If you assume R2 tensile, then your R2 here will become negative. Again here you will get the same answer, 280 kilonewton. Okay. Hello. Let's move on. This is from 2016 beta. A circular metallic rod of length 250 mm is placed between two rigid immovable walls as shown in here. Rod is in perfect contact with the wall on the left side and there is a gap of 0.2 mm on the right side. If the temperature is increased by 200 degrees centigrade, axial stress in the rod is. Now I told you, whenever you have such question, first what you need to do, if you are increasing the temperature and the length is increased by only 0.1 mm, will there be any stress here? If you are increasing the temperature and the length is increased by only 0.1 mm, will there be any stress? No. In that case, your answer will be 0. So you have to first check whether the change in length due to temperature is greater than the gap or not. So what is the change in length due to temperature? L alpha delta T. What is the length beta? 250 mm. What is the alpha beta? Alpha is 10 to the power minus 5. What is delta T? 200. So this is 0.5 mm, right? This is 0.5 mm, which is greater than the gap. Gap is only 0.2 mm. So now we are sure that there will be stress because the thermal change in length is greater than the gap. So there will be force from here, there will be stress. Now how do you calculate stress in this case? Total change in length will be equal to 0.2. Yes or no? Total change in length will be 0.2 mm because there is a gap of 0.2 mm. So total change in length will be 0.2. Out of total change in length, there will be some change in length due to temperature and some change in length due to force. We call it thermal change in length, mechanical change in length. Thermal change in length we have already calculated. Mechanical change in length is given by PL by A. Yes or no? Yes or no? But this is compressive because there will be compressive force. So 0.3 will be equal to PL by A. Now beta, can I write P by A as sigma? Sigma is equal to P by A, na? So I can put P by A equal to sigma. Sigma L by E is 0.3. Sigma will be equal to how much? This 50, 100 into 10 to the power 3 will be equal to how much? 240 megapascal. Very good, very good, excellent everyone. 240 megapascal. So this is the thermal stress developed in the bar. Okay, but if this is 0.1 mm or 0.15 mm or even 0.2 mm, answer will be 0. It has to be greater than 0.2 mm. Even if it is equal to 0.2 mm, answer will be 0. Chalo. Another question. Now this is the question from impact loading, and let me tell you, this is the only question till now. This is the only question from impact loading. So there is a chance that you might get another question from impact loading this year, na? Yes. A point mass of 100 kg is dropped onto massless elastic bar. Cross sectional area 100 mm square, length 1 meter, Young's modulus 100 gigapascal, height 10 mm. From 10 mm it is dropped. G is 10 meter per second square. Maximum compression of the elastic bar is. They are asking you the change in length due to impact. So what do you need to calculate first? First you need to calculate the change in length if the load is gradually applied. You assume that the load is gradually applied. So this is the change in length if W is gradually applied, right? This is called delta L static. What is the value of W, beta? What is the weight? Mass is 100 kg and G is 10. So weight will be 1000 Newton. What is the length? Length of the bar is 1 meter, 1000 mm. Area of the bar is 100 mm square, and Young's modulus of the bar is 100 gigapascal, means 100 into 10 to the power 3. 336. For this delta L static will be 0.1 mm. Very simple calculation, right? 0.1 mm. So if the load is gradually applied, means if this weight is gradually applied, change in length will be 0.1 mm, but it is not gradually applied. This is impact load. So now what we will calculate? We will calculate the impact factor, which is 1 plus root over 1 plus 2h upon delta L static. What is the value of H? H is 10 mm. And what is the value of delta L static? 0.1 mm. What will be the impact factor here? (15.177). Yes. So now your delta L will be equal to delta L static multiplied by impact factor. 15.177 will be 1.5177. You have to put it, you round it off to 2 decimal places, 1.52 mm. Yes. So this is the only question till now that has been asked from impact loading. Okay. Now here understand, if they ask you to calculate sigma, same concept. You have to calculate impact factor, then your sigma will be sigma static into impact factor, right? Sigma static into impact factor. Chalo. Now let's move on to the next chapter, which is torsion. Okay, we have completed material properties, we have completed axially loaded members. Now let's move on to torsion chapter. Okay, GATE 2015. Hollow shaft of 1 meter length is designed to transfer power of 30 kilowatt at 700 rpm. Okay, maximum permissible angle of twist is 1 degree. Inner diameter is 0.7 times of outer diameter. Modulus of rigidity is 80 gigapascal. Outside diameter of the shaft. Good afternoon, buddy. Good afternoon. Welcome to the session. So they have given you the inside diameter and they have given you the relation between inside and outside. Sorry, no, they have not given you any diameter. They have given you a relation between inside and outside diameter. Means this is K. K is 0.7. Then they have given you power and RPM. So first we will have to calculate the torque. Na? First we will have to calculate the torque. P is equal to 2 pi n by 6. Power is 30 kilowatt. So 30 into 10 to the power 3 watt. RPM is 700. So from here, first you get the value of torque. How much is the torque? $409.25 Newton meter. The torque, na? Chalo. Now we have angle of twist. We need to find the outside diameter. So beta, what is the angle of twist? Theta is given by TL by J. Yes. And what is J? J is pi by 32 d outer to the power 4 minus d inner to the power 4. Let me put 30 up. If I take d outer common, I will get this, where K is what? D inner by d outer, na? Put the values here. Theta is 1 degree. Remember, I have told you this multiple times. If theta is without sine cos 10, you have to put theta in radians. If sine theta is there, cos theta is there, tan theta is there, you can put it in degree, radian, whatever. But if there is only theta, you have to convert it in radians, not degree. So 1 degree means what? 1 degree means pi by 180 radian. 1 degree means pi by 180 radians. So this will become 32 T. T is 409.25 into 10 to the power 3 Newton mm. Newton meter to Newton mm. Length is how much? 1 meter means 1000 mm. What is the value of G? G is 80 gigapascal. So 80 into 10 to the power 3 gigapascal. And K is 0.7. This formula, there is only one unknown, that is D outer. So from here, what is the value of D outer you are getting? $59.27. Are you guys getting 50? Why am I? Oh, sorry, my. What about this? 44.52. 44.52 mm. Everyone is getting this? 44.52 mm. Almost 44 point something. Yes. Very good, very good. Excellent, everyone. Let's move on to next case. Now this is from GATE 2018. This is a statically indeterminate shaft. Okay. Statically indeterminate shaft, very important topic. Okay. A bar of circular cross section is clamped at P and Q. At P and Q it is fixed. Torsional moment of 150 Nm is applied here. Torsional reactions at the ends P and Q are. Now this is very easy to calculate. This is very easy to solve. First of all, you have to remember that whatever reactions will be here, sum of those reactions will be 150. Okay. So here the sum of all the 4 options is 150. Okay. Second thing, this support is closer to the load. So here the torque will be more, the reaction will be more. Means at point P, the torque will be more. So this cannot be the answer. This cannot be the answer. Both cannot be equal. Both will be equal if the load is at equal distance from both the ends. But it is closer to this end. So here the torque will be more. So this cannot be the answer. This cannot also be the answer. The only possible answer is this. Yes, the only possible answer is this, C. Right? So by elimination, you can easily solve this problem. But if they ask you this same problem in NET, we'll have to solve, na? So how do we solve this? Let's say here and here, the reactions are TP and T. Total angle of twist be equal to 0, right? So what will be the total angle of twist? Angle of twist of this part plus angle of twist of this. So angle of twist of this part will be equal to how much? Internal torque will be TP, length will be 100 divided by G. And what will be the internal torque of this part? TP minus T, or TP minus 150, length will be 200 divided by Gj. This will be TP plus 2TP minus 300 equal to 0, 3TP equal to 300. So TP equal to 100 Newton meter. And if TP is 100, TQ will be 50. Right? If TP is 100, TQ will be 50. Someone is saying D is also possible. Beta, how D will be possible? Tell me. How D will be possible? Acha, this can also be possible. Yes, you are right. You are right. D is also possible because this is P is also greater than. Sorry. D is also possible. By elimination, you cannot say whether this will be the answer or this will be the answer. You will have to solve. Okay. Chalo. One more shortcut I can give you. Say, whatever will be the ratio of their length, the torque will be in the inverse ratio. So length ratio is 1:2. So the torque ratio should be 2:1. Okay. So this will be 2:1. Na? This is 4:1. Okay. So length ratio is 1:2. So torque ratio will be 2:1. Okay. Chalo. Let's move on to this question. This is from GATE 2015. Very simple but conceptual question. Consider a stepped shaft subjected to twisting moment applied at B. Assume shear modulus of 77 gigapascal. Angle of twist at C is. What is the angle of twist at C? What is the angle of twist at C? C. The shaft is subjected to torque here. So from B to C, what is the internal torque? From B to C, what is the internal torque? What is the internal torque from B to C? If I take a section here, What is the internal torque from B to C? 0. Very good, very good. And what is the internal torque from A to B? What is the internal torque from A to B? So if I take a section here, internal torque from A to B will be equal to 10 Newton meter. Very good. Now they are asking you to calculate theta C. So theta C will be theta A to C, which is theta A to B plus B to C. For theta A to B, torque is 10 Newton meter, means 10 into 10 to the power 3 multiplied by length 500 divided by G. What is G? 77 gigapascal multiplied by J. Diameter is 20 mm. So pi by 32, 20 to the power 4. Now for B to C, torque is 0. Some 0. So from here you will get theta C in radians. Right? From here you will get theta C in radians. .133 into 10 to the power minus 3 radians. Now you will have to multiply 180 by pi here in order to convert it in degrees. So this will become 0.2368 or 0.24 degrees. Everyone getting this? 0.24. I am rounding off to 2 decimal places. So 0.24 degrees. In radians, this will be the answer. In degrees, this will be the answer. You have to multiply 180 by pi. Okay. Everyone clear? Internal torque in BC will be 0, because if you take a section in BC, on the right side of the section there is no torque. This is 0. If I take a section here, on right side there is only one torque, 10 Newton meter. So TAB will be 1 Newton meter. 10 Newton meter. Okay. Let's move on to next question. Now this is a very interesting question. This was in GATE 2016. Okay. This was a very, very interesting question of torsion. A rigid horizontal rod of length 2L is fixed to circular cylinder of radius R. See, the rod is rigid. The rod is rigid, but the cylinder is not rigid. Vertical forces are applied as shown in figure. Shear modulus is of the rod is cylinder is G and Young's modulus is E. Vertical deflection of point A is. This is point A. Understand what is happening here. See, this is a cylinder, let's say. It is attached here, and then a rod is attached to this cylinder. Now cylinder is not rigid, but the rod is rigid. Now the rod is subjected to equal and opposite vertical forces. Upward force here, downward force here. So the rod will twist, the rod will rotate, and if the rod will rotate, cylinder will be twisted like this. Right? So whatever forces you are applying to the rod, it is creating a twisting moment for the cylinder. So the cylinder is getting twisted. Let me show you in the diagram. See, this is happening. This is the cylinder. Okay. A rod is attached to this cylinder like this. This is the rod. Okay. Now, let's say this is point A and B. You are applying an upward force here and a downward force here, what will happen? This rod will be rotated. The rod will rotate and this cylinder will be twisted. At the center of the cylinder, there will be a twisting moment, right? At the center of the cylinder, there will be a twisting moment, a torque, which will be equal to how much, beta? This force multiplied by this distance. Both these forces will create a torque. So beta, what will be the force? P. And what is the distance between these two ends? 2L. So this is the total torque, 2PL. This 2PL torque will twist the cylinder. So the rods will be twisted like this. Rod is rigid, so it will remain straight. This is A dash. This is B dash. Now they are asking you to calculate this distance. They are asking you to calculate this distance. Let's say delta A. How do you calculate delta A? If let's say this is theta, then using this theta you can calculate delta A, na? What is this theta, beta? This is the angle of twist of the cylinder, na? The cylinder is getting twisted by this angle theta. So if you know this theta, you can calculate delta A. What will be the relation, beta? Tan theta, which will be almost equal to theta, will be delta A divided by L. See, this length is L. So delta A will be theta multiplied by L. Yes or no? Is everyone clear till this point? Is everyone clear till this point? The cylinder is getting twisted. The rod, which was initially like this, became like this. We need this. We have this angle. From this triangle, we can calculate delta A. Delta A will be theta into L. So all you need to do is calculate this theta. And what will be the theta? Theta will be TL by GJ. This is the torque. Torque is 2PL. What is the length of cylinder? Length of cylinder is L. What is the J in terms of R? Here the radius is given. Diameter is not given. Radius is given. So in terms of diameter, formula of J is pi by 32 d to the power 4. If you put d equal to 2r, this same formula will become pi by 2 r to the power 4. Na? So 2 and 2 will become like this. This is theta. But we need delta A, which is theta into L. Just multiply L here, will be 4PL cube by G pi r to the power, that's it, 4PL cube by G pi r to the power 4. What is the answer? D is the answer. Then everyone is clear. This diagram is very important to understand. If you understand this diagram, then there is nothing in this problem. Okay. Hello. Now this is the question of shear force and bending moment. So we have completed torsion in circular shaft. Moving on to the next chapter, which is SFD BMD. Do you know the flow of my strength of material chapters? If you have studied strength of material from me or from Ramanand sir, we both use the same flow. Okay. So first chapter is properties, second is axially loaded member, then torsion, then SFD BMD, then bending stress, then shear stress, then deflection, energy method, and complex stress, complex strain, combined loading, pressure vessel, column. Yes. So we have completed torsion. Now moving on to SFD BMD. Then after that, stresses in beams, deflection of beam, complex stress, etc. Okay. For a loaded cantilever beam of uniform section, bending moment along the length is this. Bending moment equation is given. Magnitude of shear force at x equal to 10 mm. What is the relation between shear force and bending moment? What is the relation between shear force and bending moment? This is the relation, right? So you have to just put the equation of m here. This 5x square plus 10x. So this will become 10x plus 10. But you need to remember one thing. What is the unit of s and x? You might make mistake here. So here shear force, sorry, the bending moment m is in Newton mm. So shear force will be in Newton and x is in mm. Okay, so it is very important to know what are the units of this equation. Okay, x must be in mm. So here at x equal to 10 mm, shear force will be 110 Newton. So it is your luck that the answer is 110 Newton. Otherwise, let's say here if I write x is in centimeter, then the answer will change. If x is in centimeter, then what will be the answer, beta? If here the x is in centimeter, this is Newton centimeter, then what will be the answer? Can anyone tell me? Then what will be the answer? Then the answer will be 11. Hey Bhagwan, if x is in centimeter, then at x equal to 10 mm means x equal to 1 centimeter, na? So this will become 1. So this answer will be 20 Newton. Very good. 20 Newton. Okay. See, one small change and the answer will completely change. If I just put here centimeter and centimeter, the answer will completely change. So if you don't realize this, if you don't look at the units, I told you whenever there is a question where equations are given, it is very important to see what is the unit of different variables. Keep this in mind, write it in somewhere, write it somewhere and put it on your wall. Every day you have to look at that, okay? These are some of the silly mistakes made by students, usually made by students. Radius and diameter, confusion between radius and diameter, okay? Confusion in units, putting wrong units in this equation. All these are very common mistakes, okay? If you avoid these mistakes, you can get a very good rank in GATE, okay? Chalo. Again, a question from SFD BMD for the overhanging beam. Magnitude of maximum bending moment. Where do you get the maximum bending moment, beta? Where do you get the maximum bending moment? We get maximum bending moment at the point where there is a couple or at the point where the shear force is changing sign. Okay. So here there is no couple. Here there is no couple. So here where will you get the maximum bending moment? You will get the maximum bending moment where the sign of shear force is changing. Right? So first you need to find the value of reaction. Okay, first you need to find the reactions. This is A, B, this is C, na? Chalo. Let's find the reactions first. So if I take moment at point A, what will be the equation? RB multiplied by 4 anti-clockwise minus 10 into 4 into 2 minus 20 into. So what will be the value of RB beta? What will be the value of RB? 20 plus 30, 50, na? RB is equal to 50. And if RB is equal to 50, what will be RA? RA will be equal to 10 kilonewton, right? 50 and 10. Very good. So we have got these forces. 3 kilonewton, sorry, 10 kilonewton and 50 kilonewton, right? RA 10, RB 50. Now draw the shear force diagram, not the bending moment diagram. We need shear force diagram because we need the location where the sign of shear force is changing. So here initially shear force will increase up to 10 kilonewton, from 0 to 10 kilonewton. Then it will go down 10 minus 40 minus 30, from 10 to minus 30 linearly. Then minus 30 plus 50, it will go up to 20. And then from 20 to 0. Okay. What is this? This is the shear force diagram. So the shear force is changing at 2 points. Where and where? Shear force is changing here as well as here. Now the bending moment at this point will be equal to this area, and bending moment at this point will be equal to this area. Which area is bigger? Which area is bigger? Bending moment at this point will be equal to this area. Bending moment at this point, this area is bigger. So obviously bending moment will be maximum at point B. Yes? M maximum will be at point B. What will be the answer, beta? 20 into 2, 40 kilonewton meter. 40 kilonewton meter, right? 20 into 2, 40 kilonewton. Okay. Somebody is saying this area is bigger. What can we do about these? Oh, ho, ho, ho. So sorry, so sorry. We'll go like this. Sorry, my mistake, my mistake, my mistake. Chalo. But still the answer is same. Okay. Now understand one thing. In this problem, some people will give you the direct answer that at point B the bending moment will be maximum 20 multiplied by 240. It is not necessary. Whenever you get questions like this, do not get a standard answer. Do not standardize this concept that every time bending moment will be maximum here. It will depend upon this value, it will depend upon these lengths, it will depend upon this value. Okay, so sometime you might get maximum bending moment between A and B, and sometime you might get maximum bending moment at point B. It will depend upon the values of the loads as well as these distances. If you change these distances or if you change these values, then the location will be different. You might get maximum bending moment here, you might get maximum bending moment here. So don't standardize this concept. Some people have given the standard answer. Whenever you have overhang beam, always maximum bending moment will be here. No, it's not the case. Okay, this is not a standard case. Is this point clear? You have to check every time where the shear force signs are changing, and then you have to check where the bending moment will be maximum, whether bending moment will be maximum here or here. Okay, chalo. Here we don't need to find the location of this point because we can clearly see that this area is bigger than this area. Okay, chalo. This is from GATE 2015 and this is a question of internal hinge. Let me tell you, these concepts of internal hinge are very important. Okay, almost every other year you get a question from internal hinge. Not every other year, but we have got these internal hinge problems 2-3 times. Okay, these are important concepts. A cantilever beam OP is connected to another beam PQ with a pin joint, means P is the internal hinge. Okay, a load of 10 kilonewton is applied at the midpoint of PQ. Magnitude of bending moment at the fixed end O is. They are asking you to find the maximum magnitude of bending moment. See, in order to find the bending moment at point O, you need the reaction here. So how will you get the reaction here? How will you find the reaction here? At internal hinge, bending moment must be 0, right? At internal hinge, bending moment must be 0, means bending moment at point P will be 0. Now what is bending moment? Bending moment is the moment of all the forces either on right side or left side. So the bending moment at point B, P will be equal to the bending moment of forces on the right side, RQ into 1 minus 10 into 0.5, right? RQ will be 5 kilonewton. Yes. Now we can calculate the moment at point O, bending moment at point O. So what will be the bending moment at point O? Moment of RQ will be RQ multiplied by 3, means 5 multiplied by 3. And the moment of this 10 kilonewton will be 10 multiplied by 2.5. 15 25. This will be minus 10 kilonewton. although they are only asking you the magnitude. So the correct answer will be C, 10 kilonewton. Okay. Sign depends upon our sign convention, right? If I take this negative, this positive, then the answer will be plus 10. The sign convention is different for different people. Okay. Let's solve this one. This is from GATE 2021. Overhanging beam PQR is subjected to uniformly distributed load 20 kilonewton per meter. Maximum bending stress developed in this beam is. Now see, in the last to last question, they were only asking you maximum bending moment. Here they are asking you maximum bending stress. So this is a two-step problem. In the first step, you have to calculate the maximum bending moment. Then in the second step, using that bending moment, you will calculate maximum bending stress. Okay. So how we will calculate the maximum bending moment? Same. We'll have to find out where the sign of shear force is changing, right? We'll have to find out the location where the sign of shear force is changing, and for that we have to first find out the shear force diagram. We have to find out the reactions and draw the shear force diagram. This load is 20 kilonewton per meter. Will be one reaction here, one reaction here. This is RP, RQ. This point is P, this is Q, this point R. This is 2 meters, 1 meter. If I take moment at point P, moment of RQ will be RQ multiplied by 2. Moment of UDL will be 20 into 3 into 1.5. So RQ will be 45 kilonewton, right? RQ will be 45 kilonewton. And if RQ is 45, what will be RP? RP will be 15 kilonewton, right? This is 45, right? Now draw the shear force diagram. At point P, the shear force will suddenly go up from 0 to 15. Right? Then at point Q, 15 minus 40 means minus 25. Then minus 25 plus 45 plus 20. And then 0. Where are you getting the maximum bending moment? Where are you getting the maximum bending moment? Again, this time also you are getting maximum at this point, but still I am telling you, don't make this a standard case. Don't consider it like a standard case that every time you will get maximum bending moment only. Okay, it might change. Okay, so you can see that this area, among this area and this area is bigger. Bending moment here will be maximum. So maximum bending moment is how much? You can calculate this area, na? This area will be equal to the bending moment here. So half into 1 into 20. So 10 kilonewton meter. 10 kilonewton meter is the maximum bending moment. Yes. Now if 10 kilonewton meter is the maximum bending moment, how you can calculate the maximum bending stress? See, it's a rectangular section. 24 mm by 100 mm. Width is 24, height is 100. And what is the maximum bending stress for rectangular section? Remember this formula, 6m by bh square for rectangular section. For circular section, formula becomes 32m by pi d cube. For rectangular sections, it becomes 6m by bh square. What is the value of m? M is 10 kilonewton meter. So 10 into 10 to the power 6 Newton mm. B is 24, H is 100. So what will be the value of sigma maximum beta? (250 megapascal), right? Very good, very good. 250 megapascal. This is maximum bending stress. Okay. For rectangular section, you can use this direct formula, 6m by bh. Okay. Chalo. Moving on to the next question. Now this is GATE 2019, and let me tell you, same year in 2019 there were similar question, two similar questions. Okay, there were two different sets. So in set 1 and set 2 there were similar questions from bending stress. The same concept, there were two different questions in different sets. Okay. Consider an elastic straight beam of length L equal to 10 pi meter with square cross section A equal to 5 mm, Young's modulus 200 gigapascal. The straight beam was bent in such a way that two ends meet to form a circle of mean radius r. Assuming Euler-Bernoulli beam theory, maximum tensile bending stress in the bent beam is. So you have to use Euler-Bernoulli's beam theory. Means whatever formula of bending stress we know, that is from Euler-Bernoulli beam theory only, na? Now can you find the radius of curvature? This straight beam was bent into a circle. So can you say that the perimeter of this circle will be equal to the length L? Means L will be equal to 2 pi r, or 2 pi r will be equal to L, or R will be L upon 2 pi. What is the value of L? L is 10 pi meter. So R will be 5 meters. Yes, R will be 5 meters. So how do we calculate the maximum bending stress? Use this formula. Sigma by Y equal to M by I. Sorry, M by I, E by R. So sigma maximum will be E into Y maximum by R. What is the Young's modulus? 200 gigapascal. What is Y maximum? It's a square section. Height is 5 mm. So Y maximum will be half of this height, 0.5, and R is 5 meters. So sigma maximum will be equal to 200 into 2.5 means 500 divided by 5, 100 megapascal. Yes. From the same concept, there was another similar question in 2019, a different set. Okay. So these questions based on the calculation of radius of curvature are also very important. Okay. Let's move on to the next question, and this is very easy. Okay. Simply supported beam subjected to UDL, we need to find maximum bending stress. So I told you to remember the formula of maximum bending moment for this case. Do you guys remember? Formula of maximum bending moment for simply supported beam subjected to UDL. I told you, remember the formula. WL square by 8. Very good, very good. WL square by 8. What is the value of W? 10. Length 4. So 20 kilonewton meter is the maximum bending moment. Okay. So sigma maximum will be equal to what? This is a rectangular section, again 6m by bh square. M is 20 into 10 to the power 6. B is 100. H is 200. So just put the values in the formula and you will get bending stress. How much? 30 megapascal. 30 megapascal. Very good. Excellent, excellent. Now this is from GATE 2016. In this case, you have a cantilever beam. It's a similar question. Let's move on. Now this is GATE 2016, same year. Simply supported beam of length 3L is subjected to loading shown in figure. It is given that P equal to 1 Newton, L equal to 1 meter, Young's modulus 200 gigapascal. Cross section is square with dimensions 100 mm. Bending stress at point A located at the top surface of the beam at a distance 1.5 L from the left end is. Now in this question, a lot of people made mistake. What mistake did they make? They didn't realize that the forces are opposite. They didn't notice this. They thought that both the forces are downward and they solved the problem. Okay. So this is what you can do in exams. Okay. These are very common mistakes. Not noticing the arrows. Okay. So looking at the diagram carefully is very important. Okay. Whenever you have such diagrams, you have to look at it very carefully. What are the directions? What is the distance? Where is the point? Okay, all these things. So one force is upward, one force is downward. Okay. So if you draw the free body diagram, what you are going to get? This force is upward. This force. Okay. P. Let's name these. Let's say this is A, this is B, this is C, L, L, L. First, we will have to calculate the reaction. So, net moment at point D equal to 0. So, RA into 3L plus P into 2L minus P into L equal to 0. So, from here, RA will be equal to how much? 2PL minus PL. PL divided by 3L, P by 3. RA is equal to P by 3. So from summation of Fy equal to 0, RA plus RD will be equal to P minus P 0. So RD will be minus P by 3. Okay. RA will be plus P by 3, RD will be minus P by 3. Now we have to find the So sorry. No, no issue, no issue. Let me name this point. We name this point Q. So now we need to find the bending moment at point Q. So I can find the bending moment at point Q on the left hand side, na? So RA will be multiplied by 1.5 L. This distance is L by 2. So RA multiplied by 1.5 or P by 3 multiplied by 1.5 L plus, this is minus P by 3 plus P by 3. This is negative, this is. So from here, what will be the bending moment at point Q? From here, what will be the bending moment at point Q? 0. Right? Bending moment at point Q will be 0. The answer to this question will be 0. There is no bending moment, so there will be no bending stress. Yes? There is no bending moment, there will be no bending stress. Clear? Chalo. Let's move on. Consider a simply supported beam of length 50h with rectangular cross section of depth h and width 2h. Beam carries vertical point load at its midpoint. Ratio of maximum shear stress to maximum bending stress is. We have a simply supported beam, okay, with point load at the center, and we have rectangular cross section. Let's say the load is W. It will be W by 2, W by 2. Okay. Let's say the length is L. What will be the maximum bending moment? It will be WL by 4. And what will be the maximum shear force? W by 2. Right? If you draw the shear force diagram, maximum shear force will be at the ends. W by 2, W by 2. Now you can calculate sigma maximum and tau maximum, right? Sigma maximum will be equal to 6m by h square. So here sigma maximum will be equal to how much? 6 WL by 4 divided by width is 2h and depth is h. Here sigma maximum is how much? 6 into 50 by 8, 5 by 2, or 37.5 W by h. Yes? Then tau maximum. 3 by 2 times of tau average. Maximum shear force is W by 2 and area will be h into 2h. Tau maximum will be equal to how much? 3W by 8h square, na? 3W by 8h square. So sigma maximum by tau maximum will be equal to how much? Sigma maximum is 37.5 W by H and tau maximum is 8H square, 3W by 8H square. So this will become 8H square by 3W. W will be cancelled, H will be cancelled. They are asking you tau maximum by sigma maximum by tau maximum. Tau maximum by sigma. Sorry. W by 8H square multiplied by H by 337.5 W. So H can the value of H. I am getting H here. Divided by 8 into 37.01. 01. Everyone, 0.01. I forgot that here there is H square. It will become H cube, H by H cube. So the answer is D. Hello. Now this is a very interesting problem. Okay, this is based on moment area method. This was in GATE 2021. A cantilever beam with uniform flexural rigidity is loaded with concentrated load at its free end. Area of bending moment diagram corresponding to the full length is 10,000 Newton meter square. Magnitude of slope at its free end is. Remember moment area method. What is the moment area method? To apply a force here, then the deflection curve will be like this. Elastic curve will be like this, right? If this is point A, point B, theta A minus theta B, the area between AB divided by EI. Theta B is 0. So theta A will be area between AB divided by EI, right? So here we need to find theta A. We have the area between AB, which is 10,000 Newton meter square, and EI is also in Newton meter square. So you don't need to change the units. Okay, you don't need to change the units because this is also in Newton meter square, this is also in Newton meter square. So 10,000 Newton meter square divided by 200 into 10 to the power 6. So from here theta A will be how much? Five into 10 to the power minus 5 radian. Okay, or 50 into 10 to the power minus 6 radian. I can say it is 50 microradian, right? 50 microradian. Okay, very good. Theta A is equal to 50 microradian. Very good. Chalo. Moving on to next question. This is from GATE 2021. Okay. A plane frame PQR is shown in figure. Both members PQ and QR have length L, flexural rigidity EI. Neglecting effect of axial stress and transverse shear, horizontal deflection at R is. How do you get the horizontal deflection at R? How do you get the horizontal deflection at R? By applying strain energy method, Castigliano's theorem, right? So first we will have to find the bending moment equation in PQ and QR. What will be the bending moment equation in QR? Bending moment equation in QR. Bending moment equation in QR will be F into X. Yes. Then if you transfer the force from R to Q, this will be FL F. What will be the bending moment equation in PQ? Bending moment equation in PQ will be F into L. Yes. Now we have the formula using Castigliano's theorem. Horizontal deflection of R will be integration m into del m by del f dx upon EI. Yes. So horizontal deflection of R will be integration m for QR is fx, del m by del f will be x, dx upon EI 0 to L. Then this will be FL L dx upon EI. Integrating this will give you x cube by 3 means L cube by 3. FL cube by 3 EI. Integrating this will FL cube by EI. So 1 plus 1 by 3, 3 by 3 plus 1 by 3, 4 FL cube by 3 EI. Yes. 4 FL cube by 3 EI. 4 FL square by 3. So this will be FL cube, na? Four FL cube by 3 EI. Very good. This was in GATE 2020. This is from statically indeterminate beams. A cantilever beam of length L and flexural rigidity EI stiffened by a spring of stiffness K is loaded by transverse force P. The transverse deflection under the load is. They are asking you deflection under the load, or you can say deflection of spring. This is, let's say, point A, this is point B. So YA will be equal to Y of spring. Yes or no? YA will be equal to Y of spring. So if you remove the spring, there will be a reaction force here. Let's say it is RA. So you need to find RA. Want to find deflection of A or deflection of spring, you need this RA. How do you get this RA? By compatibility equation. What is compatibility equation, beta? YA will be equal to Y of spring. Yes. Now what will be YA? So deflection at A will be due to P as well as due to RA. Due to P it will be downward, due to RA it will be upward. Okay. Now this is a cantilever beam subjected to point load. So what will be the formula of deflection? PL cube by 3EI minus RAL cube by 3EI. Okay. Now what is the stiffness of the spring? K. Y of spring will be RA by K. So from here, PL cube by 3EI will be equal to RAL cube by 3EI plus RA by K. Now you have to solve this and find the value of RA. So if I take 3EIK here, this will become KL cube plus 3EI. From here, RA will be equal to how much? 3EI, 3EI cancelled. KPL cube divided by KL cube by 3. This is the reaction at A. So what will be YA? Will be Y of spring, which is RA by K. Just divide by K. YA will be equal to KL cube by KL cube plus 3. Yes. What is the answer? A? A is the answer, na? See, this 3EI will be cancelled. So PL cube by KL cube plus 3EI. This 3EI and this 3EI, they are cancelled. PL cube divided by 3EI plus KL cube. KL cube divided by 3EI plus. Yes? We have solved the questions in class, na? Chalo. This is from GATE 2016. Now this is a very confusing question. A lot of students don't get the concept behind this question. Understand, a simply supported beam of length 2L is subjected to moment M at the midpoint. Okay. Deflection in the domain from 0 to L, x equal to 0 to L, means in this beam, in this part of the beam, equation of deflection is given by this. Okay. You have to find the slope here at x equal to 0. You know the equation of deflection, you have to find the slope. Now the problem is that here we have a constant of integration C. How do you find this value of C? You have to put some boundary condition. Now what is the boundary condition? At x equal to L, y equal to 0. First of all, you need to understand this is the part for which this is the equation of deflection. So you can't put the boundary condition here. Okay. Because this equation will give you deflection from here to here. Not a difficult question, okay? It's not a difficult question. It's a conceptual question. See, this same problem can be solved even without using this equation. Okay, the same problem. See, this is the problem, simply supported beam subjected to couple at the center. So apply Macaulay's method and solve the problem. Okay, you don't need this equation. But if you want to use this equation, then how you can solve it, that I am trying to explain. So you need to first understand that this equation is only valid for this part. Let me write the name of the points. This is A, this is B. So this equation is only valid for BC. It is not valid for entire beam. It is not valid for AB. It is only valid for BC. First point, very important to understand. Second point, if you put the boundary condition x equal to L, at x equal to L, y equal to 0, then this entire equation will become 0. You will not get the value of C. Then how we are going to find the value of C? So here you need to use another equation. Remember, I have used this equation, m equal to EI d square y by dx. Do you remember? Do you remember? M equal to EI d square y by dx square. The relation between bending moment and deflection. This is the relation between bending moment and deflection. Okay. So here beta, if you differentiate this equation twice, what you are going to get? Y is equal to minus mx. Let me put it m naught. Okay. Let me put it m naught. Otherwise you will get confused. This m is the bending moment. So m naught x by 12 EIL. To open this bracket, what you are going to get? Lx plus minus x square. Okay. dy by dx. Achha, have to multiply x in the entire equation. Lx square plus x square minus rc. Now dy by dx will give you what? Be patient, okay? 2xl plus lc x, and again differentiate this d square y by dx square. What you are going to get? L plus minus 2x minus 2 minus 2. Yes? A minute. I made a x plus l x square. Now, what is the value of m? M is I d square y by dx square. Put the value of m. EI will be cancelled. This will become minus m naught by 12L. 12 minus x. What is this? This is the equation of bending moment. Okay, the equation of bending moment. Now understand beta. At x equal to L, what will be the bending moment? 0, right? At x equal to L, bending moment will be 0, na? What will be the bending moment here? The bending moment here, 0? Say yes or no. At this end, bending moment 0. So can you use that boundary condition? At x equal to L, m will be 0. Put the value here. This will become 0 equal to plus m naught by 12L. L minus 6L minus 2. So this part is not 0, na? M naught is not 0, L is not 0. So 12 minus L minus 12 C equal to 0. This will become minus 4L minus equal to 0. What will be C? C will be minus 2L. Yes or no? C will be minus 2L. Chalo. Now, once you get this, put all the values here. Y will be equal to, now we have got the equation of y, sorry, dy by dx is nothing but theta, right? What is dy by dx? Theta minus m naught by 12 EIL QXL plus LC minus 3x square minus QXC. Now we need theta at x equal to 0, right? They are asking you theta at the midpoint, na? Theta b will be equal to minus m naught by 12 EIL. Put x equal to 0 and this is minus, so theta b will be equal to some 6 m naught divided by 6 here, right? Not L by 6i. The answer ml by 6ci. D will not be the answer, D will be the answer. This is minus 2L, L into minus 2L, so minus 2L square, so this will become 6, 1 L will be left, so m naught L by 6. So do you understand? We have first found out the equation of bending moment, m equal to EI d square y by dx square. Now the bending moment at the end C will be 0. So our boundary condition became at x equal to L, m equal to 0. Using that boundary condition we got the value of C. Okay, then we already have the equation of slope dy by dx. In this equation put x equal to 0 and C equal to minus 2L, we will get the slope. Okay, chalo. Now this is the question from GATE 2015, very simple question, direct formula based question. You already know how to solve these type of questions, right? How to find deflection of beam. Okay, then this is also a very simple question. Both these questions are based on standard conditions. I have already told you in this problem what you do. This is point A, let's say, this is point B, this is C. So YA is equal to YB plus theta B into AB. The formula that we can use in order to solve this problem, right? And in this question they are asking you the deflection here, so all you need to do is transfer the load from here to here. Just transfer the load. So if you transfer 2 kilonewton here, it will be 2 kilonewton. Kilonewton multiplied by this distance is 80 mm. That's it. Okay. Is this clear? So both these problems we have solved in class, right? Let's move on. This is a very simple problem based on superposition, right? Formula based question. What will be the answer? Formula based question based on superposition. What will be the answer? YA you have to calculate, na? So, sorry, theta A. So PL square by 2EI plus ML by EI. PL square by 2EI plus ML is PL by 2. So PL square by 2EI plus PL square by 2EI, the answer will be PL square by EI. Simple formula based question, right? Answer is B. See, in deflection you always get simple questions. Okay, most of them are simply based on the direct formula. So from deflection of beams you don't have to worry, and we have already solved ample questions from deflection of beams. We have solved very difficult level of questions from deflection of beams. Okay, so I don't think you have to worry in deflection of beams. Okay, this is another question which we have solved already in class, right? A force P is applied at a distance x from the end of the beam as shown in figure. What would be the value of x so that displacement at A is equal to 0? What do you do in this question? Just transfer the force at point A. Transfer the force at point A. What is this distance? L minus x. Na? Transfer the force at point A. So you will get this cantilever beam. P, and what will be the bending moment? Moment will be anti-clockwise, P into L minus x. Okay. Now they are saying that YA must be 0. So you can see that due to this force YA will be downward, and due to this couple YA will be upward. Okay. So due to the force YA will be PL cube by 3EI, and due to the couple YA minus L square by 2EI. So in this case, some PL cube by 3EI. Let me put right side. P value is P into L minus x. EI cancelled, P cancel, L square cancelled. What you are going to get? This some 2L equal to PL minus 3x. 3x will be equal to L. X will be by 3. Yes or no? X will be L by 3, which is 0.33 L. So you have to just shift this force, and let me tell you, this same question has been repeated, not in gate mechanical, but in different exams. Okay, in engineering services also, this same question has been asked. This is a very important question. Okay. A beam is loaded as shown in figure. Bending moment at point R is. Now in this question, let's not solve this question. Okay, let's not waste time. Let's not solve this question. Let's just discuss the concept. So in this same question, I have to discuss two concepts. One concept is, if you have an inclined force, what you are going to do? If you have an inclined force, what you have to do? You have to resolve the force in two parts. Horizontal part and vertical part. Okay. Now, if they are asking you bending moment or shear force, then you can ignore the horizontal force, because this horizontal force is an axial force. It will not produce any shear force or bending moment. Shear force and bending moments are developed due to transverse force. This is the transverse force, right? You have to just consider this 6 sin 30. The horizontal component will not be considered. This is the first point. Second point, this force is acting on the bracket. So you have to transfer this force from here to here. And if you transfer it, you will get this force 10 kilonewton and this moment 10 into this distance 1, 10 kilonewton meter. So now if you draw the free body diagram of the beam, you are going to get this. It will be 6 sin 30, 10 kilonewton, 10 kilonewton meter. That's it. Yes. And now you can calculate the bending moment at this. Find the reaction. Calculate the bending moment. Easy. Yes. So there are two concepts in this same problem. First is, if you have inclined forces and you want to calculate shear force and bending moment, ignore the horizontal component, just consider the vertical component. And second, if you have a bracket, transfer the force acting on the bracket to this point on the beam. Okay. Chalo. Now let's move on to complex stresses. Okay. The state of stress at a point under plane stress condition is given. Sigma x equal to 40 megapascal, sigma y equal to 100 megapascal, tau xy equal to 40 megapascal. Radius of Mohr circle representing the given state of stress. Just find the radius of Mohr circle. What is the formula of radius of Mohr circle? Root over sigma x minus sigma y by 2 whole square plus tau xy square, right? Simple formula. Sigma x is 40, sigma y is 100. So 40 minus 100 by 2 whole square plus 40 square. 40 minus 100, 60 by 2, 30 square. This will be 50. Right? R will be 50. Okay. In a plane stress condition, component of stress at a point are sigma x 20, sigma y 80, tau xy 40. Maximum shear stress is. If they are not writing maximum in plane shear stress, what are you going to calculate? Yes, very good. Absolute maximum. First, calculate the principal stresses. What is sigma x? 20. Sigma y? 80. And tau xy is 40. So how much will be this? 50, na? This will be also 50. Sigma 1 is 100 megapascal. Sigma 2 is 0. And sigma 3 is already 0. So tau maximum, which is maximum of sigma 1 minus 2 by 2, 2 minus 3 by 2, b minus 1 by 2. Now which one will be tau maximum, beta? There is only one tau maximum, which is 50 megapascal, right? Because two principal stresses are 0. There is only one principal stress, 100 megapascal. The answer will be 50 only. There is no confusion, no doubt here. Okay. Chalo. Now this is from GATE 2016. It's a question of stress on oblique plane. A bar of rectangular cross section, area 50 mm square, is pulled from both the sides by equal force of 100 Newton. Shear stress along the plane making an angle 45 degree with the axis shown as a dashed line is. How do you solve this problem? How do you solve this problem? See, first you need to find sigma x. Okay. Find the value of sigma x. So in x direction, the sigma will be direct force upon area. Force is 100 Newton. Area is 50. This will be 2 megapascal. So you have the value of sigma x. Now you need tau at angle theta. And what is the angle, beta? What is the angle? See, this question is like this. You have sigma x and you need to find tau at this angle theta. And this angle is anti-clockwise, so we will use it positive. 45 degree, we'll put it for positive. So tau at any angle theta is minus of sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. So this is 2 minus 0 by 2 sin 90 minus 0. What will be tau, beta? It will be 1 megapascal only. Yes or no? 1 megapascal, na? See, even if you are getting negative value, unless they have asked you to put the answer with sign, unless they have given you some sign convention, only use the magnitude. Okay. Are you getting plus 1? I am getting minus 1. How come? Minus of sigma x minus sigma y by 2, na? Everyone is getting minus 1 according to our formula. But still we will use the magnitude only because they have not mentioned you to use the sign. Have they given you any sign convention? No, right? So just put the magnitude. Okay. Okay. Chalo. The state of stress at a point for a body in plane stress is shown in figure. Minimum principal stress is 10 kilopascal and the value of sigma y is x then. Okay, sigma x is given, tau xy is given. We have to find sigma y and we have the minimum principal stress. Okay. Now in these problems, I told you the best way for solving this problem is using the concept of eigenvalues. Remember, using the concept of eigenvalues, we found two relations between the principal stresses. One relation was this. I hope you guys remember. Sigma 1 plus sigma 2 is equal to sigma x plus sigma y, and another relation was this. Sigma 1 into sigma 2 equal to sigma x into sigma y minus tau xy square. Remember these two relations? So if you use these two relations, you will get the sigma y easily. First relation is sigma 1 plus sigma 2 equal to sigma x plus sigma y, the sum of principal stress. One principal stress is 10 kilopascal, second one we don't know. So this will become sigma 10 plus sigma 2 equal to 100 plus sigma y. So from here, can I say sigma 2 equal to 90 plus sigma y? Yes, we can write it like this, 90 plus sigma. Then second relation is sigma 1 into sigma 2 equal to sigma x into sigma y minus tau xy square. Now what is sigma 1? 10. What is sigma 2? 90 plus sigma y. Sigma x 100. What is tau xy? 50. Now in this entire equation there is only one unknown, that is sigma y. So you can easily find sigma y. Right? $3,400 divided by 90. 37.77, right? What the answer? 37.77. C is the correct answer. See, you can also use the formula of principal stress for solving this problem. You can use the formula of principal stress, but the issue in this formula is, here this is sigma y, this is root over sigma y square. It will give you a very complicated equation which will not be easy to solve, right? It will give you a very complicated equation. Okay. Someone is saying sigma 2 will be minimum. Now, who told you these concepts? That sigma 1 should always be maximum, sigma 2 should always be minimum. Who told you all this? I have never taught you this, right? What is in the name? You say sigma 1 is minimum, sigma 2 is maximum, or sigma 1 is maximum, sigma 2 is minimum. Is it going to change your answer? Is it going to change anything? A thin walled principle. We have moved on to pressure vessels. A thin walled cylindrical pressure vessel of internal diameter 2 meter is designed to withstand an internal pressure of 500 kilopascal. If the allowable normal stress is 100 megapascal, minimum thickness of the vessel. So you get very easy questions from pressure vessels. Sometimes you might get some conceptual question. There was one conceptual question, very good conceptual question. Okay, see, here they have given you sigma maximum and they are asking you what should be the minimum thickness. What is sigma maximum in cylindrical pressure vessel? PD by 2, right? Now again, one more important thing. Lot of students get confused. In this formula, what should be D? Inner diameter, outer diameter, mean diameter. I told you that when we derive the formula, inner diameter, outer diameter, mean diameter, all these diameters are approximately considered as D. So whenever you have a question from pressure vessel, whatever is mentioned in the question, put it D. Whether it is inner diameter, outer diameter, mean diameter, take it as D. Okay. So here sigma is 100 megapascal. Internal pressure is 500 kilopascal, means 0.5 megapascal. Diameter is 2 meter, so 2000 mm. So what will be thickness? 5 mm. This is the minimum required thickness, 5 mm. Okay. Very good. This is again a question from oblique plane. This is on oblique plane. A carpenter glues pair of cylindrical wooden legs by bonding their end faces at angle theta equal to 30 degree as shown in figure. Glue at the interface fails if criteria 1, maximum normal stress exceeds 2.5 megapascal, criteria 2, maximum shear stress exceeds 1.5 megapascal. Assume that interface fails before the logs fail. When a uniform tensile stress of 4 megapascal is applied, the interface fails only because of criteria 1, fails only because of criteria 2, fails because of both criteria, or does not fail. What they are saying is that the glue is applied here on this plane and the sigma maximum and tau maximum of this glue is given. Sigma allowable and tau allowable. Okay, so you have to tell us that whether it will fail due to first criteria or second criteria, or whether it will fail due to both criteria, or whether it will not fail at all. So what we do is we will calculate sigma and tau on this plane. Now understand, this is very important. In their diagram, whatever theta is given, it does not necessarily mean that r theta will also be same. Okay, a lot of people make this mistake. What they do is they use whatever theta is given. So you should not do that. Okay, understand, your theta should be from vertical and your theta should be positive if it is anti-clockwise. Now their theta is also from vertical, so luckily our theta and their theta is same. Okay, see, someone again got confused. It is anti-clockwise, beta. If the plane is like this, theta is positive. If the plane is like this, theta is negative. Okay, so sigma theta and tau theta you have to calculate. First of all, sigma theta. What is the formula of sigma theta? Remember the formula: sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 plus tau xy sine. Sigma on the glue will be equal to how much? Sigma x is 4 megapascal, sigma y is 0, tau xy is also 0. What will be the value? 2 plus 2 cos 60, 3 megapascal. And this is greater than the allowable value. Allowable value is 2.5. So fails from criteria 1, right? According to criteria 1, it will fail if sigma exceeds 2.5 megapascal and sigma is 3 megapascal. So according to criteria 1, it will fail. Whether it will fail from criteria 2, let's check. So this time we will calculate tau theta minus of sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. So 2 sin 60, 1.732 megapascal, right? And it is greater than 1.5, na? It's also greater than 1.5. So according to criteria 2 also it will fail, right? According to criteria 2, it will fail if tau is greater than 1.5 and it is already 1.732. So it will fail due to both criteria. Yes? It will fail due to both criteria. C will be the correct answer. Sigma is also exceeding, tau is also exceeding, right? Chalo. Now there was one very interesting question, this one, from pressure vessel. Read the question. A thin walled cylinder of radius r and thickness t is open at both the ends. Okay, means this is the cylinder, let's say. Right now it is open at both the ends. Okay, and it fits snugly between two rigid walls. Snug fit, do you understand what is snug fit? Snug fit means, let's say there is just enough gap between two vertical walls, there is just enough gap that this will fit. Means if the length of this is, let's say, 1 meter, then the gap is also 1 meter. Just enough gap is there. Okay, just enough gap is there. 1 meter gap is there, so we have fit it. Okay, so that is called snug fit. Now what they are saying is, the material of the cylinder has Young's modulus E, Poisson's ratio nu, coefficient of thermal expansion alpha. What is the minimum rise in temperature required to prevent gas leakage if the cylinder has to store the gas at an internal pressure P of above the atmosphere? See, understand the question. What is happening? If I fill the gas in this pressure vessel, what will happen? If I fill the gas in this pressure vessel, length cannot change because it is open from both the ends, but the circumference will increase. In this direction, the pressure vessel will expand, and if the pressure vessel will expand in this direction, then in X direction it will be compressed. Yes or no? If it expands in Y direction, it will compress in X direction. So in order to prevent the leakage, you have to maintain the contact between the cylinder and the wall. Right now, let's say there is a gap of X meter. Right now, let's say due to the expansion, there is a gap of X meter. In Y direction, it is expanding. So in X direction, it is compressed. Let's say it is compressed by X meter due to pressure. So how will you expand it again? If you want to prevent the leakage, you will increase the temperature so that it will again expand by X meter and it will again come in contact. Yes or no? If due to pressure it is compressed by X meter, then due to temperature it should be expanded by X meter. Then there will be no gap. So in order to prevent leakage, epsilon x due to pressure, or you can say due to temperature, should be equal to epsilon x pressure. Yes or no? Yes or no? Hey, yes or no? Epsilon x due to temperature should be equal to epsilon x due to pressure. If both these epsilon are equal, there will be no gap. Yes? Now what will be epsilon due to temperature? Delta L due to temperature is L alpha delta T. Epsilon is delta L by L. So can I say it will be alpha delta T? Can I say it will be alpha delta T? Now what will be epsilon x due to pressure? Due to pressure, epsilon x can be written as sigma y by E. Sorry, here you are writing the equation of sigma x, na? Epsilon x, sigma x by E minus mu sigma y by E. Yes or no? But it is open from both the ends, so there will be no sigma x. So can I say it will be nu sigma y by E? Now don't worry about the negative sign, because we have to equate the magnitude. So don't put the negative sign here. We are equating the magnitude, okay? We are not equating them along with their sign. 10 is not equal to minus 10. So one will be tensile, one will be compressive. So you don't put the sign. You have to equate their magnitude. Now what will be sigma y beta? What will be the circumferential stress? Circumferential stress will be P by 2T. So from here, delta T will be equal to how much beta? In terms of R, it will be P R by T. So nu PR by alpha T, this will be the answer. Huh? Nu PR by alpha TE. Yes or no? Arey, yes or no? Done? Okay. Okay. Now this is a question again repeated 2-3 times in different exams. This same question has been repeated in GATE. Okay. Long time ago there was a question similar to this in GATE. Okay, it was a very old question. Consider a prismatic straight beam of length L equal to pi meter hinged at both the ends. Beam has square cross section of side P equal to 6 mm. Young's modulus E is 200 gigapascal and coefficient of thermal expansion alpha is 3 into 10 to the power minus 5 per Kelvin. Minimum temperature rise required to cause Euler buckling of the beam is. What is happening here? The beam is hinged at both the ends. So if you increase the temperature, then compressive forces will be developed like this. Now, in order to cause Euler buckling, this force should be at least equal to P critical, right? for buckling, according to Euler's theory, P should become at least equal to P critical. It can be more than P critical, but at least it should be equal to P critical, right? So if P should be equal to P critical, what will be the value of P beta? What will be the value of P? P is the force developed due to change in temperature. Thermal stress is E alpha delta T. Now just multiply area in the formula. So can I write it A E alpha delta T? Yes. Then what is P critical? Pi square I by LE square, and as both the ends are hinged, LE will be equal to L. So pi square EI by L square. Now E and E will be cancelled. What is the area? It's a square cross section, side 6 mm, so this will become 6 square. Alpha is 3 into 10 to the power minus 5. What is the value of I? 6 to the power 4 by 12. And what is L? Pi meter means pi into 10 to the power 3 mm. From this formula, you get the value of delta T. Pi and pi will be cancelled. 6 square will be cancelled. This will become 6 square divided by 12 into 3 into 10 to the power minus 5 into 10 to the power 6. 0.1 Kelvin. Are you getting this? 1 Kelvin? Very good, yeah. Very good, very good. 0.1 Kelvin means if you change the temperature, if you increase the temperature by 0.1 Kelvin, P will become equal to P critical and this column will buckle. If the temperature increases more than 0.1, still it will buckle. But minimum temperature rise should be 0.1 Kelvin. Minimum. Okay. Then only it will reach to P critical and the column will start to buckle. So this is a question which I think is important. It is repeated in different exams. Now one more interesting question is there from column. Otherwise there are very simple questions from column. One interesting question was this one, which was asked in GATE 2020. What is this question? The truss shown in figure has 4 members of length L and flexural rigidity EI and 1 member of length L root 2 and flexural rigidity 4 EI. The truss is loaded by forces of magnitude P. Question is, I think, incomplete. They are asking you what should be the maximum value of P so that no member is buckled. Okay, what can be the maximum value of P? Okay, safe value of P. Now understand, beta. Let's say A, B. So there are 5 members in this truss. If you have a question like this, first of all, you need to find the members which are subjected to compression. Okay, if you find the members subjected to compression, then only you can consider the buckling of those members in order to find the safe value of P. So how many members will be subjected to compression here? This is a symmetric diagram. So whatever will be the force in AB, same force will be in CD. Whatever will be the force in AC, same force will be in BD. So consider joint A. If I consider joint A, there is a force P here. Let me assume tensile force in AB and AC. Okay. This angle is 45 degrees. So you can see that FAB will be equal to P cos 45, FAC will be equal to P sin 45, and both will be tensile. I have assumed tension and I am getting positive answers, so both are tensile. But if I consider joint B or joint C, then let's see what happens. This is joint B. This is FAB, FC, and this is FB 45. So from summation of Fx equals to 0, FAB plus FBC cos 45 will be equal to 0. So FAB is how much? P cos 45 plus FB cos 45 equal to 0. So FBC will be equal to minus P, which is compressive. Can you see? This force is compressive. So there is only one member subjected to compression here. There is only one member which is subjected to compression. So there is only one possibility of failure here, that BC will fail due to buckling. So if I consider that BC fails due to buckling, P critical of BC will be equal to how much, beta? P critical of BC will be FB, sorry, pi square EI by LE, right? So FBC will be P. Now what is the flexural rigidity of this member? Flexural rigidity of this member is 4 EI and length is L root 2. So P will be equal to 2 pi square EI divided by L square. The answer will be B. Okay, 2 pi square EI by L square. Let's say there are more than one members subjected to compression, then what you will do? Can anyone tell me? If there are more than one member subjected to compression, then what you will do? If there are more than one member subjected to compression, you will consider the buckling of all the members and you will find the value of P using every member. Let's say there are two members subjected to compression. So you will find two different values of P, and whichever will be minimum will be your answer. Whichever will be minimum will be your answer. What end conditions? What are the joints in case of truss? What are the joints? What are the joints in case of truss? What are all these joints? Are they welded? What are the joints? All these joints are pin joints, na? All these joints are pin joints, na? So what will be the end condition? All the ends are hinged, both the ends are hinged. All these joints are pin joints, so both the ends are hinged. So effective length will be equal to actual length. Okay, chalo. So with this, our most expected PYQs are over. I know that some of you might be expecting that question should have been solved, that question should have been solved. But I have only considered most expected questions. I have only considered questions which I think can be repeated in GATE 2025. Okay, are you clear? So if you want the solution of every PYQ, we have already launched a PYQ book. You can see all the solutions there. I have also given you the videos. We have also given you the video solution. You can watch there. But in this session, we have tried to revise all the most expected PYQs. Okay. Now you will get the PDF in this Telegram group. So just scan this QR code or Just search for this name, find this Telegram group, join this Telegram group. Okay, now tomorrow we will be having Maha revision of strength of material. Maha revision of strength of material live in GATE wala ME channel, GATE wala mechanical channel. There will be Maha revision of strength of material where we will be revising all the concepts, all the chapters. Okay, and day after tomorrow we will be solving problems, very important unique problems, Maha Abhyas of strength of material, day after tomorrow 7 p.m. Okay, so you all are invited in those sessions. Do let me do join that session. Till then, bye bye, take care, have a great day. Jai Hind dosto. 4 p.m. timing will be